Welcome to aminacademy.com and questions how, why, what. In that, we'll discuss the answer about what are LEDs lights. Is there any light without heat? First, let us talk about what are LED lights. LED in electronics, a semiconductor device that emits infrared or visible light when charged with an electric current. LED, that is light emitting diode, displays began to be used for consumer electronics devices starting in 1968 when Hewlett Packard introduced the first LED display. Visible LED lights are used in many electronic devices as indicator lamps, car brake lights, and as alphanumeric display or even full color posters on billboards and signboards. Infrared LEDs are employed in autofocus cameras and television remote controls and also as light source in fiber optics in telecommunication system. Many uses in LEDs. The familiar but now outdated light bulb gave off light through incandescence, a phenomenon in which the heating of a wire, tungsten filament, by an electric current causes the wire to emit photons, the basic energy packets of light. Incandescent light bulbs were gradually phased out in the United States starting in 2007 with an Energy Independence and Security Act. They were fully banned in the European Union also. LEDs, on other hand, operate the electroluminescence in which the emission of photon is caused by electronic excitation of a material. The materials used most often in LED is gallium arsenide. Through there are many variations on this basic compound, such as aluminum gallium arsenide or aluminum gallium indium phosphide. LED emission is generally in the visible part of the light spectrum, that is with wavelength from zero point 0.4 to zero point 0.7 micrometer. The term diode refers to the twin terminal structure of the light emitting device. In a flashlight, for example, a wire filament is connected to a battery through two terminals, one the anode bearing the negative electric charge and the other the cathode bearing the positive charge. In LEDs, as in other semiconductor devices such as transistors, also used in electronics. In a typical LED structure, the clear epoxy dome services as a structural element is to hold the lead frame together as a lens to focus the light and as a refractive index match to permit more light in escape from LED chip. Any LED can be used as a light source for a short range fiber optic transmission system, that is over a distance of less than 100 meters. For long range fiber optics, however, the emission properties of the light source are selected to match the transmission properties of the optical fiber. In this case, the infrared LEDs are better matched than the visible light LEDs. Now we'll discuss further about what are LEDs. LED stands for light emitting diode. LED light are type of electronic light that use LEDs to produce light. They are more energy efficient, that means less power, more light, durable and versatile than other type of lighting bulbs like. How it works? Light emitting diodes LEDs work by passing an electric current through a semiconductor without causes the LEDs to emit light. This process is called electroluminescence. That means this process, electroluminescence, is light producing without heat. Without heat means less heat. How it works? When an electric current passes through the LED, electrons and holes move towards each other at the junction. The electron jumps from the electron full side to the electron deficient side. The electrons lose their extra energy and connect with the missing parts in the valence band, that is emitting light. The light is created through a process called electroluminescence. What makes LED different? First of all, efficiency. LEDs are up to 90% more efficient than incandescent light bulbs. LED produces very little heat compared to incandescent bulb and other electrical light devices. Longevity. LEDs typically don't burn out, but they do dim slowly over time. The color of the light depends on the energy required for electrons to cross the band gap, the semiconductor. How LEDs are made? LEDs are made from a semiconductor that includes gallium, arsenic, aluminium, and phosphor. The components are purified and mixed into a concentrated solution. The solution is extracted from the mixture and crystallized into a cylindrical ingot. The ingot is sliced into small pieces and polished. These are LEDs. How LED works? LED are made of two layers of crystal that are tightly pressed together. When an electric current passes through the LED, electrons move from one material to the other. The movement of electrons releases energy in the form of photons, which are the basic units of electromagnetic radiations. The color of light depends on the material used in the LED. The color of the LED depends on the material used in LED. What are the benefits of LED lights? Energy efficient. Of course, it is energy efficient. LEDs use at least 75% less energy than incandescent normal bulbs. LEDs last longer than incandescent and fluorescent bulbs. Versatile. LEDs can emit light in a range of colors including red, green, blue, and white. LEDs emit light in a specific direction unlike incandescent and CFL bulbs. Uses of LED lights: residential lighting, industrial lighting, floodlights, reading lights, and accent lights. Now, this interesting question: is there any light without heat? That means light must be produced, but without heat. That means very, very less heat, sometimes fully no heat. Yes, it is possible to produce light without heat. This phenomenon is called heatless light or cool light. How it happened? Look at this chemical reaction. Some chemical reactions can produce light without heat. These reactions are called chemiluminescent reaction. Chemiluminescent reactions. The chemiluminescent reaction is a chemical reaction that produces light but no heat. Explanation. During the chemiluminescent reaction, the chemical reaction creates a molecule in an excited state which then emits light as it returns to its ground state. Example of this reaction. Some examples of this reaction, chemiluminescent reactions, include limonal and hydrogen peroxide. This reaction is often used in forensic science to detect blood. When sprayed on a suspected blood stain, the iron in the blood's hemoglobin acts as a catalyst, causing a blue glow to appear. White phosphorus and moisture. This reaction produces a green glow. Bioluminescence. This is a term for chemiluminescence that occurs in living organisms such as fireflies, mushroom, and jellyfish. Uses of this reaction. Chemiluminescence can be used for many purposes, including imaging and immunology. This reaction have high sensitive and low background, making them useful for imaging the immunoassay. Detecting metal ions. Chemiluminescence can be used to determine the concentration of specific metal ion. Developing chemical sensors. Chemiluminescence can be used to develop chemical sensors to pollutant like nitric oxide. Living organism. Many living organisms produce heatless light, including fireflies, anglerfish, some jellyfish. LED emitting diodes produces light without heat. Some LED's light produces light without heat. We cannot say exactly. Some very little heat. That means more efficient in light. Photomolecular effect. Light can vaporize water without heat through a process called photomolecular effect. For example, fireflies. Fireflies produce light without heat through a chemiluminescence reactions. LED bulbs produces light without heat, making them more efficient than traditional light sources because it produces very less heat that fully it uses for producing light. Light introduced evaporation. Light induced evaporation. Light can trigger water evaporation without heat at the interface where water and air meet. This phenomenon may play a role in the formation of fog and clouds. So far, we discussed the explanation. Is there any possibilities to produce light without heat? As well, what are LEDs? We have done. Please subscribe our YouTube channel.